So thank you, everyone. Welcome to In Rhythm's Lightning Talks. For those who do not know me, I am Jen Crawford, and I have the pleasure of co-hosting this learning space. If you are new to Lightning Talks, each Thursday at 5:15 p.m. Eastern, you can feed your curiosity for technical knowledge by tuning in to learn from one of our amazing practice area consultants and grow with the phenomenal bar raisers that make up In Rhythm. This week, we have the lovely pleasure of having Shanker, who is one of our directors of software engineering here at In Rhythm, speak about Kafka, its strong points and features. With that being said, I'm excited to learn all that has to do with Kafka. And with that, I will hand it over to you, Shanker.
Great. Thank you, Jen. So that is surprising because I believe more than 50% of the Fortune 100 companies use Kafka. So it's very prevalent. Probably it's not widespread in terms of everybody having to have their hands on it. But if you have ever ridden a Uber, watched Netflix, used Facebook, you are touching Kafka somewhere. Okay, so everybody is using Kafka nowadays. All right, so as a motivation for why Kafka, what is Kafka, right? I wanted to share this picture, which seemed pretty interesting way of telling about software. So back in the 90s, the software was like spaghetti, because you would copy paste and, there was a little order. I would say spaghetti and meatballs because object orientation started coming in. And that was the norm back then. Then when internet boomed, and then we had this layered architecture where you would have UI layer, you have application layer, then you have a database layer. And very quickly that turned out to be not a scalable solution or easily scalable solution. The Amazons of the world ran into the limitations pretty soon as they kept growing. And then you had these monolithic applications, which became hard to maintain, and we moved to microservices, which are independent service applications that talk to each other to deliver a complete functionality. Okay, so how do they talk to each other? So there are a couple of ways. One is you have a service which would call another service, wait for its response, then it would call another service, wait for its response, and so on, assemble the results and deliver finally what it has to. Okay, this is a request-driven, service-oriented architecture. Okay. The downside of this is each service is, calling others synchronously, waiting for the response, and then assembling the results. This led to certain large monolithic structure in terms of the flow, as well as for the inefficiencies between the calls when one service calls the other. The emerging way is to do it asynchronously, where services just post an event to an event bus, which gets picked up by another service and then it responds to it. So nobody is waiting on anybody. They're all saying this is happening and then something else is happening and they keep picking it up and then exchanging that. Okay, so because it is asynchronous, this way of delivering not only gives you the smaller modularity of services, which are easier to maintain, they also enable a more efficient use of resources. And that's where Kafka comes in. It is one of the high volume, high performing message bus out there. So what does it do? Really, it's a publish subscribe messaging service that can be used for event-driven systems that I just spoke about. It could also be used for linear streams. For example, in my previous company, we were collecting electric meter data that is coming from individual meters. That's all coming as a stream, and you need to process that. You need to transform it. You could do all that with Kafka. And then we spoke about microservices, a way to link them. So when you are a Netflix with 15,000 microservices running at a time, then the message bus becomes very, very important in terms of how quickly and how reliably it can deliver. It does this using a distributed commit write-ahead log. I'll talk more about this. This is pretty interesting in terms of what Kafka was able to innovate there. So before I go further into Kafka, some key concepts to get things out of the way. So the messages that flow in this message bus are in topics. So if you're a New York Times, you might have a main page as a topic, sports news as a topic, and so on. So these are categories of messages that fall in a bucket. And there are producers that write to a topic and consumers that read from one. And then they send each other messages that contain headers. The headers contain which topic it has to go to, which partition. I'll talk more about partition. This is the key to understanding Kafka. When it was created, because Kafka ensures that messages are delivered in the order in which they were produced. So the timestamp is very, very important here. And then there is a key and a value. Key is the ID for the message, and this is what drives what the partition is usually. Okay. And then there are brokers, which are the actual Kafka servers that are doing the job of reading from producers and sending it to consumers. And then it uses replication to ensure that there is no single point of failure. So there is high availability. When any of the broker machines go down, it will be picked up by other brokers. So pictorially, this is how it looks. Producers write to topics and consumers read from topics. And if you notice, all these are individual pipes of messages that are partitions. Okay. And the consumers are reading specific partitions. Now, this is the key to scalability, because what Kafka has done is basically made all these high volume of messages go in parallel by creating pipes, which are dividing that messages into different flows. Okay, and then the consumers can run in parallel and read from these pipes. All right. So that's how it has scaled it. But then it, leveled the game up by doing a few things more that we'll talk about. So, hold on. Yeah. Just for illustration, if you see, I think Kafka is next serious. This is a variation of Kafka. So next serious competitor is Pulsar. I don't know much about RocketMQ, but this is roughly not even a half to third the performance of Kafka in terms of the volume of messages it's able to deliver. None of the others even come close. So it's an order of magnitude improvement in performance they have been able to achieve. And the way it does that is by using partitions, which is a append to log and reading from the log. So how does it look? So in a partition, you have messages going in a sequence. Okay, this is in the order of the time. Okay, and the consumers pull messages based on an offset. Okay, the consumer is the one that is telling the broker, saying, give me messages starting from 3 or m+1 and so on. Okay, so they have to keep track of what they have finished reading and what they are yet to read. There are some advantages to this. There are some others like RabbitMQ, which push messages to the consumer based on their capacity. But this pull model has its advantages in that the broker doesn't have to keep track of what has been read, and it doesn't have to figure out whether the consumer is able to catch up or not. It is leaving up to the consumer to do that. Sorry. Okay. Now, how do they achieve this performance? I think this is the most important slide in this whole thing. If you can take this away, you have learned something about Kafka. What is interesting is if you look at like reading a random disk. Okay, this is what we associate with a database. A database reads from a disk. It is 10,000 times slower than a randomly reading from memory. So memory is that much faster. Okay, I think we all know that. But then because of that, we have a limit on how much volume we can process, because usually memory is much less than the disk we can store in. Okay, if you have a 64 MB RAM, you probably have terabytes of database you could have, and it's a huge difference in what you can process. The way Kafka did when they were working on LinkedIn was they figured out that if you write logs in sequence, okay, you're just writing logs, you're not going randomly, you're going in sequence. If you do that, its performance is not that bad compared to memory. Okay, it in fact matches random memory access, and it's only about like what 4 times to 5 times slower than sequential memory access. So this change is what gives it that enormous performance advantage, and it's able to scale in terms of the volume of messages it handles. Okay, so that is one. The other one I think they have innovated on is, instead of letting the data from the disk go to this is the normal sequence that that an application goes through, where it reads from the disk, copies it to its buffer, then writes to the socket, which goes to the network card, and then it goes out. This is the sequence in which it flows. But by making the OS do this flow, you can cut those 2 copies and then make it faster. So this is the other way with they have increased the performance. Now, just for comparison again, this comes from the Confluent team, the company that has commercialized Kafka. The performance, like I was saying here, it's probably about half to third when it comes to the next big player here, Pulsar, and then RabbitMQ, which is a very popular queuing system, is much lower than Kafka when it comes to big volumes. When you have not everything is a big volume problem. When you have smaller volumes, like 30,000 messages a second or something like that, you can go with RabbitMQ pretty successfully. It has more features also compared to Kafka in some areas. So it's not all messages. I mean, if you look at Activision, maker of Call of Duty, they use Kafka quite a bit. And some of the use cases are Activision does that, and Uber, whenever you have riders and drivers riding, and the data goes back to consumers who are going to know where the next available cab is. So all that is flowing through Kafka. So it's a huge deal for Uber to be able to run their business. Okay. Similarly, this is from Tinder, where all their client access goes through Kafka. And then they have search engines which does recommendations and so on. So Kafka is like the backbone for many of these companies where high user interaction is happening. Just for example, like usage volumes, like sorry, this slide didn't come out well. I think I missed the version where I updated this. So we are talking about trillions of messages a day, okay, or billions at least. So this is the kind of volumes they are using it for. And there are some numbers on the brokers and so on. Okay. Oh, sorry, I didn't delete that. Yeah. So these are some of the popular users. Now, from here, I'll go to some of the newer features. I think they recently introduced KSQL DB, which gives you the ability to query Kafka messages using SQL. Okay, and what this does is, because you can have embed KSQL in the flow of the stream of messages, it simplifies the infrastructure quite a bit, because you don't need additional place to store and process. So you have the streams flowing through Kafka, and then you can create additional streams or tables or materialize views for querying using SQL. Similarly, KSQL DB enables like a single package to handle a bunch of things before you do additional processing. Therefore, it moves a lot of the processing in separate applications into one box. The other major initiative from them, which I'm really curious about, we haven't used this, is object storage. So apart from the broker's local disk where the messages are kept, it can also write and read from something like S3, which is gives you a lot more space to store messages. So It's interesting that a message broker is somehow moving towards becoming a data storage in addition. So I'm not, like I said, I've not used this before, but this is a new development that has come in one of the recent versions. So this is pretty interesting to watch where the move is by these different infrastructure providers on what features they bring into the product. So this makes it like a huge storage to query apart from streaming and messaging. Okay.